Hello, this is Jakob Fein with Farata Systems, and we are continuing our training on Java, Introduction to Java and Java EE. Today is Unit 2, Introduction to Object-Oriented Programming. First of all, you need to know that there are two major ways of writing programs, in object-oriented way or in functional way. Functional programming versus object-oriented programming. Java is one of the languages that are object-oriented programming languages, and we'll talk about it. What does it mean to be object-oriented? First of all, in Java, everything is an object. You write a so-called class. For example, there could be class cars. There could be class animals. And then you create specific instances of this class. Class can contain properties, sometimes they're called attributes, which are variables that you define in the class. And class can contain methods, or methods represent behavior, actions, what a class can do. For example, a class car can have properties like color of the car, number of doors, and so on. And it can have methods like start engine, stop engine, the actions. Classes can be inherited from each other. We will learn and see in action all these things today. So if I have a class car, I can create another class, for example, Cadillac, based on the class car. Not from scratch, but based on something that we put inside the definition of the class cars. We'll look at it later on. In general, there is a definition that a programming language can be considered as object-oriented if it supports inheritance, encapsulation, and polymorphism. Java is a language that supports all these features, and during this course you will see how they are applicable, how we will be using them. I'll stress them as we learn this material. Each program in Java has at least one class. Last time on Unit 1, we created a simple class that prints hello world, but it was a class anyway. It was a class with one method main, right? Next, the class car. Let's look at it, how we can define a class car. You write the keyword class and you give a name to the class, car, right? So this name is, we start the name from capital letters. This is a naming convention in Java. All classes start with capital letters. All variables and method names start with small letters. And if a name consists of more than one word, we capitalize each consecutive word. You will see it a bit later, or actually you can even see it over here. In the variable, look at this. There's a variable number of doors. The name of the variable consists of 3 words, number of doors. We always start with a small letter, the name of the variable, but each consecutive word starts with a capital. The class starts with a capital. The method's name starts with a small. Stop engine. Engine, the next word starts with capital. Let's look at these variables where we define them. If you can see, we have the variable color and the variable number of doors defined on the class level. These two variables are not defined inside any method, right? They are defined inside the class, but outside of any of the methods, which make them class variables or member variables. They are accessible from within any of the methods on the class. For example, if inside the method start engine I decide to use the variable color or number of doors, of course I can use them. They are visible. They will live in this example until the instance of the class lives. And every method can reuse them. On the other hand, there is another variable. Look at this one. Integer temp counter. This variable is defined inside the method, which makes this variable local. This variable can be used only inside this method. It's not visible outside. When the method is finished executing, the variable is destroyed automatically by so-called garbage collector. We'll talk about it a bit later, not today. What else you need to know or learn from this slide? Java is statically typed language versus dynamically typed languages, like JavaScript, for example. Java, what does it mean to be statically typed? It means that you have to declare a variable before you can use it. You cannot just on the fly just say, all right, I'm going to add the variables to this class during the code execution. It's not going to work in Java, but it does work in dynamic languages, as we call them. So to use a variable color, for example, you need to define it first. And as you can see, I decided that the variable color in my example will have type string. Why? Because I'm planning to store colors of the car as text. Text is a string. On the other hand, I decided that the number of doors in the car will have the type of int or integer. So you cannot have 2.5 doors in the car, right? So that's why we don't need other data types like float, for example, or what else, or double in Java. If you need decimals, you can use those types, but we don't need them here. Integer is sufficient in our case. What else we can see here? The method start engine, it has the keyword void in front of it, which means that it doesn't return any value. So the calculation that may be happening inside the method will not return any value. The same applies to stop engine. Also, I didn't put any code in these methods, I just put a comment. As you can see, if a line of code starts with 2 slashes, it means that it's a single line comment. If you wanted to write a block of comments, you would be starting it with the slash asterisk, then you write as many lines as you want and close this block of comments with a asterisk slash. There is one more type of comments that is used by utility Java doc. If you would start a comment with slash asterisk asterisk one after the other, in that case you would be this comment could be extracted afterward by that utility that would create a nice HTML document which describes your code, describes your class. Describes by what? By those comments that you would put in these blocks of comments that start with slash star star and end with star slash. This class has no main method. Last time, in the last lesson, we had a class with a main method, which made that class runnable, invocable. We could start it as a program. This class doesn't have a main method, which means that we cannot run this class car as a program. I did it on purpose, and why I did it this way? Because I'm planning to create another class which will create instances of the car and will call its method. And I will illustrate it shortly. Go to the next slide. How many cars can you create? When you define a class, you can consider yourself as an engineer who creates a blueprint of something. Let's say you create a blueprint of a car. How many cars you can build and put on the road based on this blueprint? As many as you want, right? As many as you can based on your factory and so on. So the same here. If you define a class car, you can create multiple instances of this car. Instance is an object. Class is not an object. Class is a definition of an object. But based on this definition, we can create object of this type. So technically, think of it this way. A class is a type. Java has a bunch of their own types, but you can create your own types. Whenever you create a class, for example, a class car, you technically define a new data type that didn't exist in Java. Car, in your case, or maybe an order, or maybe a customer. These are all new data types that you can define. And these types can be instantiated. So how to do that? Let's see. First, as I said, in statically typed language, you have to declare a variable of this type. We define a new type car, and now we declare a variable car1 of the type car. To create an instance of this class, or an instance of this object, I'd rather say, you use the new keyword in Java, new car. After that, the variable car1 points at the object that was created in memory. It's a special memory in Java called heap memory. It's a special area where all new objects are created. Where exactly this object was created in memory? In Java, they say you don't need to know exact location in memory of this object. We'll give you a reference into your variable. So in this example, the variable car1 will have a reference to some place in memory where the object car exists or was created by Java runtime. On the next line, I create another instance of the car, the same data type car, but I create a second object. Now the reference variable car2 will point at a different location in memory. Car1 and car2, if you will compare them, they will have different addresses inside. But we don't need to worry about addresses in memory in Java. Accordingly, since we created two instances of the same type car, they won't be intermixing in any way, and you can have, and each of these objects will have its own set of attributes. For example, we can paint car1 in blue and car2 in red. How do you do this? To access properties or methods of an object, you use this reference variable and then you use dot notation. Reference variable name, dot, and name of something that exists inside that was defined inside this class. Like in this case, car1 dot color is equal, and then you assign a value. Car2 dot color is equal, and you assign the value. So one object will have blue and one object will have red in their variables color. Where do we create these instances? We will create a main method in a separate class. It's not a must. Of course, I could have created the main method inside the class car, but I don't want to do this because the car just defines the car. It's not a program that's supposed to be running on its own. And typically, you will have a project which will have dozens or maybe hundreds of files, hundreds of classes, and only one of them will have a class. Only one of these classes will have a method main, which will be a starting point of your application. In this example, I will define another class called TestCar, which will have nothing else but a main method. In this main method, I will create these two instances of the car, as I explained in the previous slide, and then I will paint them to blue and red. After that, I will print on the system console using system out println. I will print a message: these cars have been painted. And in the first walkthrough, it's something that you have to do in the class if you would be sitting in the class, but I will show you all this now by myself. In this example, in this walkthrough, I am asking students to create a new Java project. In Eclipse, I wanted to call it OOP. In there, I will create a new class and define it. I will call it car. Then I create a second class called TestCar. And from there, I will instantiate two cars, and then I will run it and we'll see the output. I'll switch to Eclipse for a minute, and in there I already have it. I already created this project from my previous group, but if I would do it from scratch, I would do right click in the navigator. Actually, let's go to Package Explorer, right click, new Java project. I would enter the project over here, but I already did it, so I don't need to do this. Now in the folder src, I created a bunch of classes, but how would you do it from scratch? Select src, right click, new class. What's the name of the class? I would have entered car, right? But I already did this. I don't need a main method and so on. So I created the class car. It's right there. It has exactly the same code as we had on the slide. 2 properties, color, and number of doors, and 2 methods, start engine, stop engine. I also want you to see something. As you can see in my Eclipse, every line is numbered. It may be convenient, especially when you're trying to debug something or you see an error which points at some line number. So see this vertical gray bar. If I will do right click on it, there is an option show line numbers. You click on it, in my case it hidden it, and if I will click again, it'll show me the line numbers in this program. So the class car is ready. Now the class TestCar is here. Again, it has exactly the same code as in the slide. In the previous group, when I was recording another video with the same code, I made a mistake. I created a bug, and I will show you this bug, what happened in that case, and how I debugged it. But for now, let's run it. This code is clean. Right click, run as. I do right click on the test car, right? Run as Java application. At the bottom, you can see it printed properly. I've painted the car. The color of car 1 is, and I concatenated the value of the car1.color. To concatenate means to glue together. I have a piece of a string. The color of car 1 is, and then I want to attach a value, right? So to access this value, I am using reference variable car1 dot and the property. Now let me show you the bug. By mistake, obviously I will explain you. I will start with the bug first. This is what I did. I made this mistake because I did copy paste, of course, and when you do copy paste programming, you always make mistake. So don't do it. So this is what happened. So I ran the program, and this is what I saw. Look at this output. The color of car 1 is red, and the color of car 2 is null. Null is a special value. It's not 0, it's null. It means nothing. It means that the value of the car 2 is not even initialized. It has nothing in there. Null. So when I look at this output, I look at the code. Obviously, I am very smart, and I can debug these kind of programs with this complexity easy. But say you are not as professionally savvy in Java as I am. So you don't know what happened, right? Assume. Pretend. So what I did, I decided, let me debug it. And I wanted to debug this program as if I don't know what the error is, just to demonstrate you the debugger in Eclipse. Debuggers are used to run a program step by step and to see the values of objects or maybe variables, or maybe you want to trace the path, how the program is being executed in a slow motion, so to speak. You want to see what's going on in memory. And again, you do this mainly in complex program when you cannot immediately catch the error. Please don't confuse syntax error. Syntax errors are easy. You forgot to put somewhere a semicolon, or you misspelled the name of the class, and that's the error. But we are not talking about simple errors, right? We are talking about something that is tricky. And then you want to go through memory step by step. So to debug a program, you also right-click on the program. Not only one, you can invoke debugger from the toolbar. See this little bug over here? You can run from there as well. So instead of selecting run as, I will select debug as. Debug as Java application. To debug it and to stop it during the execution, you need to put a breakpoint. How to put a breakpoint? On this vertical bar, you need to put a breakpoint starting from the moment where you are not sure what's going on. Let's put it, for example, right on the line number 7. Say we have no clue what's going on, and we want to start debugging immediately. When I do right click on this vertical gray bar, I see a menu, and one of the items says toggle breakpoint. Click once and it'll put this little bullet over there. If I will run a program in a debug mode, as soon as the program execution will reach the breakpoint, it'll stop and it'll bring me the debug perspective. When you'll do it for the very first time, you may see a message saying Eclipse want to open up the debug perspective. Do you want to do this? Say yes. In my case, it won't give me this message because I already did it and I already said yes, I am fine with opening debug perspective. Debug as Java application. See, it hits the breakpoint, and now it's a different perspective, a different set of views on my workbench. Look at this. On the line 7, or next to line 7, you see this little blue arrow on the left, right? So this is where we are now. We are standing before executing this line. On top of this screen, you can see the variables. You can see the variables view where you can see what we have in there for now in our program. So far, the only variable we have is args, which was a parameter of the main method. We didn't give any external value to our program. I'll explain you a bit later. These are so-called command line options that you can pass to the program. We'll do it later. But let's concentrate on our variables. We are declaring a variable of type car. So I want to do one step. I want to go through one step in this program. Look at this little curvy yellow arrow on top. Step over. When you are standing in right before executing of some line of code, you can select step over. You can select step into. Step into is right next to it over here. Step into. If I would want to execute a method inside of a class, and if I would care to see what's happening inside that method and step through every line of that method, I would have selected step into. But if you just want to execute this line without getting inside, just do step over. So I click step over. Look at this, the view variables. Now we see another variable defined, right? I open it up and I see that my variable is a complex data type. It has two properties, color and number of doors right there. Color is null. Initial value of a string is null. It's not initialized. It's empty. And the number of doors, initially it's an integer variable. It's initialized with 0 by default. All right, so let me do another step over. See, it created another variable car2. Now I am assigning the value blue to the property color of the first car. Again, I will do step over. See? Now this property color has a value of blue. So far, so good. No errors, right? And now I'm standing on line 11. Again, let's pretend that I don't see that I am about to override the blue value with the red value because I made a mistake. Instead of using car2, I put car1. Step over. Ooh, I see immediately that it was the first car was blue and I repainted it over, right, with red color. And it's not what I intended to do, right? So now it gives me a clue. Oh, I understand it was a mistake. I look at it and I will fix it. So to finish the debugging process, I can either kill the debugger by using terminate button, this red square, or I can hit resume, which will continue running the program sequentially without being in a step-by-step mode. So unless it'll run into another breakpoint, which it will not in my case, it'll finish the execution of the program. All right, so I understand what was the problem. I go back to the Java perspective. I fix again. I fix car2 to car1 to car2, save, and rerun it. And now the program will work correctly. Right, blue and red. Alrighty, let's go back to the slides. Walkthrough 1 is done. Now let's learn the concept of inheritance. Inheritance. Let's create a new car. Let's define a new car, which will be the car for James Bond. The James Bond, the Agent 007. He has great cars. His cars can fly. They can go down under the water and so on. There can be some weapon on their car, but it's still a car. It has 4 wheels, right? It has doors. So inheritance means that we can define one data type based on another, on existing one. So we don't want to define the car for James Bond from scratch. We want to use the definition of the class car as a foundation, so to speak, as a superclass, as an ancestor for the class James Bond car. So how to do something like that? How to inherit one class from the other? There's a keyword called extends in Java. If you write class A extends B, it means that the class A will have everything that was defined in the class. What did they say? If class A extends class B, right? So that it means that class A will have everything that was defined in class B, plus something else that we will define right inside the class A. Java supports single inheritance only. It cannot, you cannot say, like, say a person, each of you inherited something from your father and your mother, right? So you are inherited from 2 objects, so to speak. In Java, you cannot do that. It can be, you can inherit only from one class. So class James Bond car extends car. So in here, I define only things that are specific to James Bond's car. I don't redefine the variable color, which is defined in the ancestor already. I don't define the variable number of doors. I don't redefine the method start engine, stop engine. All that will be reused because it's already defined in the class car. In here, in James Bond car, I define only whatever is new, addition to what we have in the class car. So what I have, current submerged depth. The car can go under the water, right? So we want to keep track of where we are, how deep we went. Is gun on board, and the manufacturer. Let me comment on some of these important things here. First of all, something new for you, Boolean data type. Boolean is a data type that can have values only true or false, right? So is gun on board? It's either true or false. In my case, I declare the variable, and in Java you can not only declare a variable, but at the same time you can initialize it. In one-liner, I do is gun, I do definition of the variable, and equal true is initializing of the variable. What else is new for you? String manufacturer. First of all, there is a keyword final, which you didn't know, we didn't learn yet. Final means if the variable is declared as final, it means that you can assign the value to this variable only once. You cannot assign a different value during the program execution, only once. So we want to define the final variable manufacturer who produced this car, and we want it to be final. Using Java naming conventions, variables which are final are all capitalized. Next, I also defined a couple of more methods in this class. Submerge, go under the water, or go back, surface. Some code can go there. You see, in case of submerge, I defined the value of 50 feet, for example, the initial submerged depth of the variable. So based on what we've done so far, the James Bond car class will have total of 5 variables, 5 member variables, and 4 methods. I already explained you all this, that there are variables, there are constants, and the word final means final variable. In this section in the middle, again, I'm reiterating that in statically typed languages, you first have to declare a variable, and only after that you can use it. Final variable you can initialize only once. If you assign this Toyota, there is no way that you will change it. And to be honest with you, why would you change the manufacturer of the car? I mean, you cannot undo and redo the car. Let's look at another example of the class. It's from a different business domain, so to speak. Let's say we are writing a program for accountants. And these accountants need to calculate tax. So when I design a program, I am asking to myself, what kind of classes do I want to have? And I decided that I want to create a class tax. What do I need to know to calculate tax for a customer? Say I need to know the gross income of this person, the state where the person lives. In the United States, at least, they may have different tax laws, and the number of dependents. So that's why I declared 3 variables, 3 class variables, or 3 member variables to store these values that will be eventually used in the tax calculations. So these are properties. And where's the action? I define a method called calc_tax. This is an action. So calc_tax should take the values in these variables, gross income, state, dependents, apply some algorithm, and calculate tax. And what is new for you in this method? In front of the method, in the method signature, you see the word double, keyword double. Double is a data type in Java that store decimal numbers of double precision. So if you see anything other than void in front of the method name, it means that this method returns the value of this type. In this case, it's supposed to return the value of type double. And how do you return a value? This is a very simple method. In this method, I return $264.55 no matter what. I don't even do any tax calculation. I ignore the value of gross income, state, dependence for now, to make things simple. But if you specify that the method returns some type, you must have somewhere in a method return value. Return is a keyword in Java, so you have to put somewhere return. If you will forget to do this, then compiler will give you an error. All right, so let's see how we can proceed with this tax. Again, let me repeat. Class tax is not a runnable program. I didn't put main method in there. But let me create another class called TestTax. This class will instantiate tax and then invoke a method calc_tax on it. So let's see how we do this. I define a class TestTax, which has a method main, right, to make it a program. And what do I do in there? First of all, I create a new instance of the class tax, which will create an object in heap memory. And what do we get back? We get back a reference variable, which knows where exactly in memory this object text was created. See, when I speak, once in a while I make this mistake, but I want to make it clear to you. Make a distinction between the class and the object. The class is a blueprint. The object is an instance of this blueprint with specific properties. So we create a new instance of the class tax. It'll be placed somewhere in memory, this yellow area. And then we initialize the variables, gross income, dependence, and state right there. Now this instance knows that this person, the customer of this accounting office, it has the income of $50,000 in annual income. It has two dependents, and he lives or she lives in New Jersey, state of New Jersey. Now this, so see the class variables were initialized in the tax object. Now we want to calculate the tax. Again, you use this T reference variable to access this particular instance of the tax, and you call on it the method calctax. When we said that the method returns a value, the next question you may ask, returns to whom? If it throws the ball to you, somebody has to catch this ball, right? So, and this is how it works. Whatever, if I declare a variable and put it on the left side of the equal sign, this is a place where the returned value will go. So after this line is executed, the variable your tax will have the value, remember, $254.55. Is it so? So no, $234.55. No, I want you to note one other thing. Note the types. If the method return was defined as return double, we declare a variable of the corresponding type double. And finally, we print the result. So again, I do concatenation over here. The static text, your tax is, and then I concatenate the value of the variable your tax. And you may say, how can this work? We understand the string concatenation, when you concatenate two pieces of string, but in this case we concatenate a string and a number, a double value. Java is smart enough to understand that if you are concatenating something other than string to a string, it'll convert it into a string first, and then it will glue together with this piece your text is. And now the if statement. Obviously you don't like the fact that our text program always returns the same value, $234.55. We want to do some kind of a branch out. We want to change the workflow of the program based on some criteria. As you know, people with different income are taxed differently, at least in the United States of America. So say if you make more money, you may have to pay larger taxes. You may fall into so-called different tax bracket. If you earned less, you may pay less in taxes. So how to write a program that will return or apply different business logic based on some value, in our case based on the gross income? There is an if statement which you can use for this. So in the if statement in Java, you put a condition that return Boolean, true or false. This condition or actual expression will be evaluated, and it'll be either true or false. In this slide, I didn't do taxes, but I did order prices. But it's a similar situation. Say, for example, you have a store, online store, and if a person spends so much money on the online store, less than 200, you want to give them 20% discount. If the person spent between $200 and $300, you want to give a 25% discount. If the person spent more than $300 in your store, you want to give them 30% discount. So how to write something like this? If, say for example, we have a variable total order price somewhere defined and it has a value, so we compare if it's less or equal 200, then the program execution will go into this area, into this block of code. Block of code is one or more lines of code which we placed between the curly braces. System out println, you'll get a 20% discount. What if it's not true, that if this expression evaluates to false, maybe you spent more than $200, then the program will go into the else statement. It could be either just simple else, or you can write another if you have more than one condition to test. So, all right, so we know that it's not less than 200, but what else? We care about the range between $200 and $300. We have a special use case for that. So I write another statement, else if total price is greater than 200 and 2% is one of the way to write and, logical and. Both conditions must be true. It's greater than 200 and less than 300. If the total order price falls into this range, the program will print, you'll get 25% discount. I just want to stress that the program execution will go into only into one of these blocks of code in curly braces. And the final case is else, no more ifs. If for any orders over $300, we give 30% discount. Now let's go back to the text and use if statement over there as well. So what is this walkthrough number 2? We are having these object-oriented, the same OOP project. In there, I will add a couple of more classes, text and test text, with the content of the slide that we already went through. And what else I will do? I will run this test text. I will observe that, yes, we always have $235.55 as a text, right? And then I will modify this method called text to put some business logic in there. I will put an if statement in there, and I will be charging 6%, not charging, applying 6% to the gross income as tax. If the gross income is less than 50,000, and 8% as a tax if the income is greater than 50,000. Let's go to Eclipse again. And I already created this class tax. Number of dependents, gross income state, the same thing as you saw in the slide, but I added the if statement in there. If gross income is less than $50,000, I will do the calculation with immediate return. Gross income multiplied by 0.06, which is 6%. Return the result of this multiplication. Otherwise, I'll be multiplying by 8%, right? I will take I will take this gross income, the value of the variable, and I will multiply it by 0.08 and return it as a result. The program test text. Okay, these are some leftovers from the previous group, but let us fix it real quick. I want to instantiate the class text. One second. Your text. I want to instantiate the class text line number 7. Then I initialize the variables of this instance. Say the person made $40,000, has 2 dependents, and lives in the state of New Jersey. And then I call the method calcText on this object. Return will be placed in the variable yourText, and I will concatenate it to system in the system out println statement. Let's run this program, TestCar. Run as. All right, it went through, and it prints your text is $2,400. It took $40,000. Apparently it went under the case when the income is less than 50,000 and applied 6%. But let's see how it works. Let's go again to the debugger, and in this case I want you to see how the step into will work. I put a breakpoint over here right before I call the method yourText, the method calcText. Right click, debug as Java application. We are standing on line number 15, right before invoking the method calctext. Let's look at this object T. At this point, our object T has these values, 40,000, 2, and nj. So far, the variable your text is not shown here because it was not even declared yet. We are still standing before running line number 15. In this case, I want to step inside the calctext method and see how it's going to go in there. So I will select this step into feature. Step into. See, it took me right inside the method calctext. Now we are about to check, to evaluate this expression. Is gross income less than $50,000? Under the word this is a special keyword in Java that represents the current object where we are. This code is being executed inside the object text. The keyword this represent our object where we are now. So I will do step over now, and see, we went into the case gross income less than $50,000. That's why we applied the formula gross income multiplied by 6%. And let me resume the program execution. It calculated the text as 2,400. Now let's change the value of gross income. Let's where is the text test text? Let's say I will do $80,000. Save. If I will rerun it now, we will go through a different branch. Now the gross income greater than $50,000 and the different formula will be applied. Let's do debug again. Right click, debug as Java application. We are standing here, step into. We are about to evaluate this expression, gross income. Let's see. Gross income is $80,000. Step over. See, now we are going to a different case, to a different code block, line 16. We will apply the formula of 8% of $80,000, which will be 6,400. So we can branch out the program using the if statement. Fine. Is there any other way to specify different path of execution for the program other than if? Yes. And the keyword switch, it's a special Java construct that allow you to do something similar. When you have many different conditions to check, if this, do this, otherwise do that, otherwise do this. Of course, you can write it using if statement, but the program is a little bit less readable. Whereas if you will use a switch statement, the program will look a bit nicer and cleaner. Say, for example, we have a text code programmed somewhere in a library, and there is a function, the method called getTextCode. We give a gross income to this function, and it will apply some business logic and return me the integer, which is the text code or maybe text bracket, just a number. And then, based on this text code, I can apply different execution path. For example, if the text code is 0, the following two lines will be executed: system out, println, text exempt, and break. If the text code is 1, only this section will be executed, low text bracket. If the text code is 2, only this section is executed, high text bracket. And if none of the above, the code will go in the default section. What I want to stress over here, there is a statement, again, it's also Java keyword break. Break technically means jump out of here. Finish execution of this switch statement and go and execute the next line, which is below the switch statement. What's going to happen if you will forget to put the break statement over here? You will create a so-called fall through situation. If you will forget to put this break, this program will, and let's say the text code is 0, the program will print text exempt, and then it's going to fall through to the case number 1, and it'll also print the low text bracket, and then it'll run into break, and only after it'll jump out of this break to another code. Just keep it in mind that if you will not put a break in there, it'll be a mistake. Maybe it's not a mistake. Maybe this is what you want. Maybe there are situations when you want more than one case statement to be processed similarly. But still, remember. And they use these kind of examples. If you will go through one of these multiple choice certification exams on Java, they will, on purpose, they will forget writing a break statement there, and they will give you a choice what this code will print. Some people will assume that only one of the section or one of the case statement will be executed, but it's not exactly true. You need to put your break statement properly. Finally, change in syntax. As of Java 7, you are allowed to use not only numbers. What else? There was something else, not just the numbers. I think single characters as well. But now you can use text. You can use text string type in the switch statement. Case rich, do something. Case poor, do something else. But again, this works only only from Java 7 and above. Next topic is method arguments. In many cases, we had empty parentheses in our examples. Only once in the main method we had something between the parentheses. It was system arguments, the array. But let's look at the business applications. For example, if you want to take a loan, you want to create a loan calculator. Say a user can enter the amount of loan, and say we want it to be always integer. The user will enter somewhere on the UI the number of month and state. Again, it's in the United States where he lives. This method calc loan payment will calculate based on these arguments. It will calculate the monthly payment. So arguments, or we call them parameters, methods is a way to pass some values to the method from outside. So when you invoke the method, if a method allows so many arguments, you can put these values in this method invocation, and these methods will be used. These arguments will be used inside the method. So, for example, the method calc loan payment can be invoked like this. So you call it, and it's 20,000. We pass three values: 20,000. Say I want to borrow $20,000 for 60 months, and I live in New York. So these three arguments will go inside the method. Now in this purple area, I show you a method call that will, in this example, will generate an error. See, I'm calling this method calc loan payment with only two arguments. Java will try to find, do I have a method with a signature that has two arguments of these types? Not in this case. We never define a method that can take two arguments. In this case, compiler will give you an error. Compiler will think, so to speak. They define a method with three arguments, and they call with two. I have no idea where to find such a method with such signature, so I'm going to give them an error. Is there any way to fix that situation? Yes, there is. It's so-called method overloading, and we'll talk about it in a minute. But now let's continue with inheritance. Let's look at another example of inheritance. Say, for example, we want to add some functionality to the text class. To add the functionality, you don't have to change the code of the class. You can create a subclass. This way we will have everything that the class has already, plus we can add something else. Let's see. I define a class called NJText, New Jersey Text. which extends text. So class NJText is based on the class text. So we want to add something to it. Maybe the state of New Jersey, they decided to implement a law which will lower the tax for families with students. It lowers the tax by $500. So we want to define a new method, adjust for students. This method will take one argument, the tax that was calculated already before, and it'll do adjustment of the tax. It'll take this value, do minus 500, and return the result. So the final text will be 500 less. Small definition. And if you want to use this class, we want to create an instance of NJText. Keep it in mind, since NJText is inherited from text, when we create an instance of this object will have everything that we define in text, all the functionality of the text, plus all the functionality of the NJText in this case. So how to use it? We call on this object. First we call calcText method, and then the result of the calcText we give as an argument to the method adjust for students. And finally we'll get the resulting text. We again, just to get used to the terminology, the class text would be ancestor, or sometimes we call it a superclass. The class NJText is a descendant, or sometimes we call it a subclass. Next topic, method overriding. Override, to suppress. Say for example, we have a class text which has a bunch of different methods with a bunch of different logic, and we like it, but there is a particular case that we don't like. One method is not working to our liking, to our algorithm. Maybe for all other states in the United States it's fine, but in our state we have something different. So we want to override it. We can override it. How to override it? To override a method, you need to have a situation with a superclass and subclass. So if you will define a subclass, and if this subclass will have a method with exactly the same signature as a method in a superclass, so this is basically overriding. Only the method in a subclass will take place. And let's look at the code. In this walkthrough, we want to have a class NJText that will have a method that will also have a method calcText. And this method calcText will have the same signature as in the superclass. So we will have a situation where we have two classes, text and descendant NJText. In each of these classes we will have a definition of a calcText. The definition of the method calcText in the subclass will override the definition of this method in the class text. So in this calcText in New Jersey, maybe they decided to implement different tax rates, and they want to charge not 6 and 8% as they did before, but 10% and 13% accordingly. So let's see how this can be done. Back to Eclipse, Java perspective, NJText. First of all, I wrote adjust for student over there, but what I did also, I defined a method with exactly the same signature as in a superclass. And in there I applied different formula, 10% and 13%. Now to test this in action, I will need to instantiate the class New Jersey text, declaring a variable of this type and instantiating it. Then I do tcalcText, and that's about it. So what do we expect now? We expect that the new formula will be applied, 10% or 13% based on the income. Let's run it. Actually, let's debug it. Debug is Java application. We are standing right before the tax calculation. The values are $80,000, and I will do step into. See, we are in the method calc tax, which has 10% and 13%, and we will never execute the other methods inside the class tax. We have overridden that calc tax method. Just to prove it, I want to open up this tax class. See, it still has a method calc tax, but it has 6 and 8%. But we've overridden this method with 10 and 13% accordingly. Okay, let's move on. Let's move on. On the next slide, we'll talk about method overloading. Overloading is a situation when you technically overload a name. You'll have more than one method with the same name. It's not overriding, don't confuse. There will be a difference. In overriding, you will have more than one method with the same name in ancestor descendant, but they have exactly the same signature. With the method overloading, they will have different signatures, and they may be sitting in the same class. For example, the same method calc loan payment. If I want to allow developers to call this method with either 2 or 3 arguments. For example, we are operating mainly in state of New York for this loan company, and we want to give a convenience to developers. If we can tell them, if you want, you can call our method. Say I am developing this tax calculation package. You can call the method calc loan payment with either 2 or 3 arguments. If you're going to call it with 2 arguments, we will assume that it's for state of New York. Otherwise, please specify the state. And how to do this? You need to declare 2 methods with the same name. See this? Calc loan payment here and calc loan payment there. But the first method has 2 arguments, and the second method has 3 arguments. So what are we doing there? If somebody will decide to call the calc loan payment providing only amount and number of month, we will we will call another method, calc loan payment, specifying New York as a 3rd argument. If somebody wants to call directly calc loan payment with 3 arguments, fine, only this signature will be working. So compiler, actually not compiler in this case, during the runtime, when somebody will be calling a method with 2 arguments, the runtime will find a matching method and will apply either this method or that method. This is called method overloading. And as I put it down there on the pink area, you can overload methods in the same class. You can provide more than one version of the same method, but with different arguments. One is sitting in the superclass, the other in the subclass. It's all still a method overloading. Special methods, constructors. So far, you've seen situation when you create an instance of a class. For example, TestX. Look at this, line number 7. You say new text and you put parentheses at the end. Parentheses is technically a part of the method invocation. We invoke a method, we give a name, and we put parentheses in there, with or without argument. But what about here? We don't technically call a method. Are we, or we are not? Actually, we are. There are special methods called constructors. Why they are special? They are special because they are called only once. when you create an instance in memory of your object, when you create an instance, this constructor is applied. You can say, we never created any constructor so far. How come we were able to put these parentheses? New text. And the reason is, if you will not create a constructor, Java will apply default constructor with no arguments, which does nothing special. Or you can create a constructor. So what are so special about them? Constructor must have the same exact name as a class. See this? This is a constructor named tags, and the class is named tags as well. Also, they cannot return a value. It's a method, but you don't put anything in front of it. Also, even though they don't return anything, you don't put the method void in front of it. What for are these constructors? Typically, we use them for short code fragments, most likely to initialize some important variables during the construction of the instance. Like in this case, we created a constructor which has 3 arguments: GI for gross income, ST for state, and depend for dependence. So in this constructor, we take the arguments, the values from the argument, whatever is given to us, and we assign them, we place them to the corresponding member variables. So the value of GI we put in gross income. The value of ST we put in the variable state. And the value in depend we put in dependence. So during the construction of this instance, we can immediately initialize the variables. And how would you call how would you instantiate such a class if you have a constructor with 3 arguments? Just like I highlighted over there. Text T is equal new text, for example, $40,000 CA and 4. California and 4 dependents. And this is about it. This is about it for today. As a homework, you need to study lessons 3 and 4 from the textbook and do the assignment from the try it section. And I give you a bunch of additional reading, so you will have some important materials, in my opinion, which will help you in studying this material. Thank you very much. Until next time. What I'm planning to do, I'm planning to add another unit with the recording. I will either record it from scratch, or maybe I will reuse one of the recordings that I had before with an introduction to version control system. In my case, I'm going to be using Git version control system and GitHub as a public repository for our code, for code samples. Thank you very much for coming. This was Yakov Fein with Farata Systems.